What's up, everyone? Welcome back. Patrick here, and moving on to the next limit, we got to find the limit as x approaches 0 of tan of 6x squared plus sine squared of 5x all over 7x squared. So notice that in this case, can't plug in 0 because this 7x squared is going to be 0, the denominator is going to be 0, and then also the numerator is going to end up being 0. So we got to go about this in a different way. The way you do this is you actually split up this function first into two separate functions. So we would have tan of 6x squared over 7x squared. And then we're going to have plus sine squared 5x over 7x squared. Like that. And now what we can do is we can actually look at both of these separately. We can use the properties of limits, so we'll have the limit as x approaches 0 of tan of 6x squared over 7x squared plus the limit as x approaches 0 of sine squared 5x. Now another way to write that is we can just write sine of 5x times sine of 5x. Like that. You know what? Let's put this in brackets there. All over 7x squared. And so now what we would do here is, remember, these are trig limits, and so we're going to try to use that property, the limit as theta approaches 0 of sine of theta over theta, because we know that that's going to equal 1. And so here what we would do is we would convert the tan 6x squared, so we'd have the limit as x approaches 0 of sine of 6x squared over cos of 6x squared. And then we're going to be multiplying this by 1 over 7x squared. Like that. Dividing by 7x squared is the same as multiplying by 1 over 7x squared. Right? Just took this tan and converted it. And then here, what I'm going to do, so we got this entire expression. What I'm going to do here is I'm actually going to factor out the 7. So I'm going to have a 1 over 7 out front. And then I'll have the limit as x approaches 0 of sine of 5x over x times the limit as x approaches 0 of sine of 5x over x, like that. Okay, so basically I took out this 7, then I split up this x into two separate x's, and then I just made that whole limit, I distributed it to both of those expressions. And so from here what you want to do is I'm going to take this 7x squared, I'm going to put it with this sine 6x squared. This is going to be over 7x squared, like that. And then this 1 over cos 6x squared, that's going to be its own thing, its own limit. So I'll have the limit as x approaches 0 of 1 over cos of 6x squared, like that. And then I'm going to have 1 over 7. Basically, these two limits are the same thing. So I'll have the limit as x approaches 0 of sine of 5x over x, and then all of that is going to be squared, because these two are the same thing. So it's basically that to the power of 2. And then from here, what we can do is I'm just going to look at each of these brackets separately. All right, and the easiest one to actually look at is this bracket here, because we could do a direct substitution. If we plug in 0 for x, cos of 0 is just 1 over 1. That ends up being 1. But these two brackets are a little bit more complex. So this here, I'm going to do on the side. So if I got the limit as x approaches 0 of sine of 6x squared over 7x squared, I'm going to take the 7, I'm actually going to factor it out. Okay, so sorry, let me split this up. This is just the work for that. What I'm going to do is I'm actually going to multiply this by 6 over 6. So I can get this 6x squared the same as that 6x squared. So what I would end up with, this 6 I'm going to bring out, so I'll have 6 over 7. Then I'll have the limit as x approaches 0 of sine of 6x squared over 6x squared. And then we can do that change of variable that we did in the trig limits lecture videos, which I highly recommend you watch if you're not too comfortable with trig limits. I go over a bunch of examples and go over the fundamentals of how these limits work. But basically this, we know we can change this to 6 over 7 limit as theta approaches 0 of sine of theta over theta. We could let theta equal that 6x squared, right? And then this is equal to 1. So 6 over 7 times 1, that gives us 6 over 7. So this whole limit here, this whole bracket, is going to end up being 6 over 7. And then all that's left to do is to work with this bracket. So this is going to be plus 1 over 7. And then I'm just going to work with this limit on the side here. So we'll have the limit as x approaches 0 of sine of 5x over x. I can multiply this by 5 over 5. Bring the 5 out. So I took this, put it here, took the 5, brought it out. And then this is that fundamental trig limit. If we let theta equal 5x, we would end up with 5 times the limit as theta approaches 0 of sine theta over theta, which equals 5 times 1, which is equal to 5. So this would be 5, but we're squaring that bracket right there. And then from here, all you have to do is algebra. So we would have 6 over 7 times 1, which is 6 over 7. And then 5 to the power 2 is 25. 25 times 1 over 7 is 25 over 7. So we would end up with 31 over 7. So that there ends up being the final answer to this limit. Split it up, converted the tan to sine over cos, and then just worked trig limits. 31 over 7 is the final answer.